Here we're given the graph of a function and we are asked to graph its derivative. The way we do this is ask ourselves, where is the original function decreasing and increasing? We see that initially this function is decreasing on the interval from negative infinity up to negative 2, and it's decreasing at a constant rate. In fact, this slope is down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. That sounds kind of repetitive, I know. It turns out that slope is negative 1. So because the slope of this entire chunk is negative 1, our derivative has a value of negative 1 because derivative is synonymous with slope. Now don't forget, it takes on this value of negative 1, or the slope is negative 1, all the way up until negative 2. After which point, the function starts to decrease rather rapidly, but then starts to increase. So we're looking for the next part of our derivative graph will be negative, then positive, because after all, the function is decreasing, then increasing. So we're going to start down here. It's decreasing rather steeply. So it's decreasing and then increasing, because our derivative is negative, then positive. And this happens up until, I think, 3. So this is going to be 3 over here. And then the last thing to point out is that on the last leg, this is a steeper slope. This is down 2 over 1, down 2 over 1, down 2 over 1. So this is a slope of negative 2, not of negative 1. So because of that, it's a constant slope of negative 2. This line is going to be a little bit lower than the line we see here because this is a steeper slope and therefore more negative. And as a result, this is the graph of our derivative.